What do we know about circles? Well, we know that the diameter passes through the center and touches the edges. The radius goes from the center to an edge. And there's also something called a chord, which cuts across, but it doesn't pass through a center. So if we're looking at a circle, this is the diameter, this is the radius, and this is a chord. The area of a circle is pi r squared. The circumference of a circle can either take the form of pi times the diameter or 2 pi times the radius. This should make sense because the diameter is just 2 times the radius. So if we replace the d with 2r, we come up with the other version of the formula. We also know that circles have an internal angle of 360 degrees. So if we take this line and sweep it all the way through that circle, that should be a 360-degree angle. We also know that the area is nonlinear. What in the formula tells us that? Well, look at the formula for area, A equals pi r squared. And what we talked about with variation is that this squared means that something is quadratic, not linear. The circumference of a circle is 27.4 millimeters. What's the radius? Round your answer to 3 significant digits. And the reason we're rounding to 3 significant digits is because the circumference has 3 significant digits, 27.4. So since the circumference is 2 times pi times the radius, what we can do to find the radius when we're given the circumference is to take the circumference, 27.4, equals 2 pi times the radius. Simply divide both sides by 2 pi to find the radius. In this case, my calculator says this is 4.360845, which is far more accurate or precise of a number than we can really expect to get from this measurement. So rounding this to 3 significant digits, the 4, the 3, and the 6 are all significant. So looking at our rounding rules, we will be rounding down and leaving our answer as 4.36 millimeters. Let's do a problem. Let's say we want to build a circular walkway that's 3 feet wide around a circular pool with a diameter of 10 feet. What is the area of the walkway? So this is not drawn to scale, but this is 3 feet, and then the diameter of the pool is 10 feet. If we're talking about area, diameter is less useful than radius. So instead of saying the diameter is 10 feet, let's just say that the radius is 5 feet. To find the area of the walkway, I can't simply take the area of a circle with a radius of 3. Area is nonlinear, so we need to think about a different way to figure this out. What makes most sense to me is to think of this as an area of a big circle minus the area of a smaller circle, of the pool. So for the big circle, the radius is not 3. The radius would go from the center of that pool all the way to the edge of the walkway. Since the center of the pool to the edge of the pool is 5, the center to the edge of the walkway would be 8, 5 plus 3. Since area equals pi r squared, the area of the big circle would be pi times 8 squared, or 64 pi. The area of the pool is pi times 5 squared, or 25 pi. 64 pi minus 24 pi is 39 pi. And keeping pi in there made some of my calculations a little bit easier. But now we should use the pi button on our calculator to figure this out. Note about that, frequently using 3.14 as an approximation might not always be accurate enough. Using the pi button is better practice. So on my calculator, I got that this is 122.5221. And this is feet squared. This is a more accurate number than we can really claim. So looking at our measurements, we have 2 significant figures here and 3 significant figures here, so our answer should only have 2 significant figures. So that's the limiting factor. So the 1 and 2 should be significant, which means we're going to round to the nearest 10. Looking at the number past the 10, at that 2 in the 1's place, that tells us that we round down, and so our answer is actually 120 square feet. One more problem. This seems tricky, but it's more straightforward than you might think. A rectangular piece of insulation is to be wrapped around a pipe 4.75 inches in diameter. How wide in inches does the rectangular piece need to be? And to really imagine this, it's almost like we're slicing this insulation off and unrolling it. And when we unroll it, it should be a rectangle. It should be a mat of insulation that we've rolled around this pipe. I know that the diameter of the pipe is 4.75 inches, so what we're interested in is the circumference of this pipe, right? Because if we snipped that circle there and laid it flat, we'd have that edge right there. So that edge is the circumference of that circle. What is the circumference of a circle when we're given the diameter? Circumference equals pi times the diameter, so that means the circumference, or the width of this rectangle, would be pi times 4.75. Multiplying those together, and I've got 14.922565. Again, that's more precise or more accurate than we really can make a claim to. And this is just in inches since it's length, not inches squared, like I almost wrote. I see that the measurement that we have has 3 significant figures, so precision. Since we're dealing with like a perimeter, we need to think about precision, not number of significant figures. So we need to think about the place value. The place value is precise to the nearest hundredth, so our answer should be precise to the nearest hundredth. 14.92 inches is our answer. Thank you.